This is an old oscilloscope that I drug out of the closet here at the physics lab. Um, More modern oscilloscopes are smaller than this and use a little bit different screen technology, but this one's useful because it allows us to make observations about the direction of the force that a magnetic field exerts on a moving charge. So I'm going to go ahead and turn the oscilloscope on and give it a moment to warm up. Um, Generally, you would use this when you were studying some sort of electric circuit, maybe an electric circuit that had an alternating current in it. Um, and well, here's a line on the screen that's a trace there, and perhaps you'd be looking at a waveform with this. But I'm just going to put it in the mode that puts a single dot onto the screen. So there is, for simplification purposes, an electron gun in the back of the electroscope that fires charges forward onto the screen. And when those electrons hit the screen, they hit a phosphorescent material that makes that little glow that you see on the screen. It's the same basic technology that was used to make the earliest televisions. So I have that bright dot in the middle of the screen, but the important thing to remember is that is a charge, an electron, coming from the back of the oscilloscope towards the front of the oscilloscope, so towards you, the observer. And what we want to do is make observations about what happens to the position of that dot on the screen when I bring a magnet into the picture. So I have a stack of magnets here that I've put together and labeled the north end and south end of. So there's my dot in the middle of the screen. I'm going to start by bringing a north end of a magnet down towards that beam. And then if I pull it away, beam returns to where it was. If I flip my magnet around so that now I have a south end pointing down, when I bring that toward the beam is deflected to your right. And I can try the same on the side. So here is north coming in from the side of the screen. You see that beam gets deflected downward. If I flip it around and bring south in toward the screen, the beam gets deflected upward. What's important to note in these observations is that we have to think three-dimensionally. We've got a direction of the velocity of the beam toward the screen. We had a magnetic field that when we started out was in the vertical direction, and we observed horizontal deflection of the beam. Then when we relocated the magnetic field to be in the horizontal direction, we observed vertical deflection of this electron beam.